Hey robot makers, hope you're having a good day so far. So do you deserve a crisp high five but there's no one there to give you your reward? Then you need to build a high five bot, and then this is the show for you. So let's dive straight in Mindscaping. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our Keynote. So yes, this is all about high five bot. But this is also my 400th video, so I was hoping to do something really cool and fun for you, and had a bit of a disaster. My 3D printer decided to create this great big blob of, well, I don't even know what this is. So luckily I do have some spares, so I'm hoping I can just swap this out and get that thing up and running. So here's to my 400th video. So yes, this is all about Hi-Fi Bot. It's a simple Raspberry Pi Pico 2-base robot, and it uses an ultrasonic rangefinder to measure distance, and it also has one of these, it's got a very unusual name, 28BYJ-48 stepper motor. So they often come with this little driver board as well. I've got 5 of these in a little kit. So I'll be building some more robots in the future with these, and I thought this is quite a fun little project just to get to learn how to use these stepper motor drivers. So the stepper motors, how do they work? Depending on what type of stepper motor you have, it might be a 2-phase or a 5-phase sequence. So the coils, which are around the outside of the stepper motor, they get energized in different phases. So in this 2-phase one, you can see they've got phase A, phase B, and we've got all these little magnets around the very core, and as the phases are energized, it attracts the core towards them. And if you do that in a particular sequence, you can get the stepper motor to turn very, very accurately. And it will only turn when you change the phase, and it'll only turn one step, hence stepper motor. So the sequence of phases to activate the turns requires this one step at a time, and I'll actually show you how we will do this in our code, because the drivers for these are pretty crude. You don't just provide the number of steps, you actually have to say what the sequence is and walk through that one bit at a time. It's quite cool to actually play with. So here we are, this is the 28BYJ-48 stepper motor. They're very cheap, very, very reliable, and very, very quiet as well. So if you want to make a robot that's got very accurate motors that can turn, you can use a pair of these and you can make a usual kind of like a burger bot or a tank type robot. So they do need a driver board to move the motor, and the little driver board that comes with these kits, this is based on this ULN 2003 driver board. So that's the name of the chip that's on there. If I just get that into focus there for a second. So you can see there's like a little chip in the middle, and there's a bunch of pins around the edge. So there's 4 pins for controlling the 4 different inputs to it. Essentially they're part of the phasing, and one of them is a common ground. So the ground is actually from the 5 volts in and the ground that you provide on the bottom of this as well. There's quite a few pins that we need to use to drive each one of these. So let's have a look at the design and assembly of our robot, shall we? So I was thinking, let's start very, very basic. Let's create something that can hold this stepper motor in a kind of square base. I actually got this wrong the first time I printed it. Rather than printing out the entire thing again, I thought I'll just print out a little spacer just to give it a bit of extra height. So you'll see that in a second. So there's the stepper motor kind of in place. The model that I've got, the depth isn't quite the right height. So the 3D model worked fine, but when I came to print it, I had to do this little white stepper. So this little stepper is a bit of a bodge, but it's basically quicker than printing the entire thing again. And I only got halfway through reprinting my other version. This is part of the base of that one there, because my 3D printer decided to print this instead. He thought this was far more creative. So a bit of super glue can hold this spacer in place. I didn't design any kind of fancy mechanism for holding that in place. And then we've got the hand. So this hand is going to rotate around the stepper motor and give you your crisp high five. So it's going to go 90 degrees from one position behind the robot to the side. That's the idea. We could have 2 of these, but for this particular robot, we just need 1 high five. You don't high five with 2 hands often. It's usually just the 1 hand, isn't it? That's what I'm going with. So that attaches nicely onto the stepper motor. The stepper motor itself, if I just hold one of these close to the camera, you might be able to see it has a kind of circular spindle but with 2 flat sides. So it makes it really easy to make things that fit onto that. So the top fits on just to hide the inner workings, and again we can have a touch of super glue. I've actually not glued mine on because I might want to do things at this robot, so for now I've just left that as it is. We can glue that into place with just a spot of super glue. I've got some Gorilla Glue for that. Other brands are available. And then there's the hood. I thought this would give the robot quite a unique look. So it's an unusual kind of shape. It's not just circular. It's got it's kind of a trapezium shape with really, really soft edges to it. So this provides somewhere for the rangefinder to sit inside, and it also provides a sort of stop for the face piece that we're printing as well. So the face piece looks very, very similar to this. You can see it's kind of got quite an interesting shape to it. And it's kind of got that cute factor. It's like a large forehead and big eyes. So the shelf inside has, it doesn't require support structures because it's at a 45-degree angle. So when you're printing this, you can print it from the bottom up and it won't require any support. So it's really, really quick to print this one. I say really quick, it still takes a couple of hours to print. You get the idea. So the rangefinder is going to sit inside there. It's going to sit within the face piece, so it's simply just going to push fit the rangefinder through these little holes here, and the friction fit, because they're so tightly tolerated, will hold it in place. So we do need a place for the wires to exit. So at the very back of this, I'll show you that in a second or two. But you can see here we've got the face piece that goes in. That's also got a nice sort of curve to it as well. I use the loft feature, if you know what that is, in Fusion 360, to give it a nice kind of curvature. So the rangefinder is pushed in from the back, and it's probably best to actually put the wires in place before you start pushing that in, because it'd be really fiddly to do once it's in place there. So that's what the full assembly looks like. We've got the head glued to the top piece there, and if we look at this from the back, you'll see, just ignore that weirdness that's gone on just here. That was just me not moving the model up correctly because I've not actually attached these. But that bit there is ever so slightly curved so that the hood can fit on nicely in place. And then there's another back piece, and that's for the Pico to be held in place. I've got these really, really small little, I think the M2 screws, and these have got like a little hexagonal thing on them, just to make it easier to sort of screw them in place. So the holes on this are also 2mm, so they actually screw in quite nicely. You get a bit of a friction fit with them. You don't actually need the bolt behind it. But you can see there's that little cutout there, and that's to allow the rangefinder cables to come out of the back of the robot head and connect to the Pico. So yes, you've got the choice of having those 4 M2 screws and bolts. You don't actually have to have the Pico mounted there, but I just thought it'd look quite tidy if we did that. So if you like these kinds of videos and you want me to make more of these, please do give this video a like. Drop me a comment, let me know if you've had any 3D printing disasters such as this blob here, and how you resolve that. And if you haven't subscribed as well to the channel, please subscribe. It means so much to me. It'd be really, really cool if next year we get to over 50,000, 60,000 subscribers. That'd be really, really cool. I do go live as well every single Sunday at 7 o'clock, rain or shine, no matter what time of year it is. So if you want to join in the fun, you can do that on our live show. Cool. So this is how I wired it up. I used Fritzing to do this diagram, just if anybody's wondering. And the components, I think I had to find these online as like a downloadable thing to put into Fritzing, because it didn't know about these kind of off the shelf. But it did know about a Pico, so I am using like a Pico 2, I think it is in there, not the W. It doesn't need Wi-Fi, so nice and simple. And there's a whole bunch of pins being used there, so you can see at the very top, the orange cable is going to the Echo orange, the trigger is yellow, that's going to pin 1, we've got the ground and the voltage for the rangefinder, because it's a 3-volt version, it's just coming off that 3-volt supply, which is like the 5th one down on the right hand side. Then we have all the 4 pins that are required for the stepper motor. We'll get into what they actually do in a second. So they go from pins 10, 11, 12, 13 to IN 1, 2 and 3 and 4 on the on this little thing. And this requires either 3 or 5 volts. It says 5 volts on it, but I've actually got it running on the desk here at 3.3 volts. So it's more than good enough. I guess it might just slip if it's under any kind of load, but it certainly turns around at 3 volts. So we can connect that to the VSys pin on our Raspberry Pi Pico. So as long as we've got USB power coming in, we'll get a full 5 volts there as well. And we've just got the ground there too. So that's the wiring for this robot. It's quite straightforward and simple. And then let's have a look at some of the code, shall we? So what I'll do, I'll just pop out to me for a second, load up Thonny, and let's have a look at the stepper motor first. So what I will do, I'll load up the stepper motor. This is the driver that I've written for this. So I've just given it the class name BYJ28. You can't start a class name with numbers. MicroPython really doesn't like that. It has to start with a letter. So it's a bit weird that we're calling it that. It really should be the 28BYJ, but that's what I've called it for now. That's fine. We then need to take in 4 pins that correspond to those IN pins, those input pins on the stepper motor driver board. So we just need to have 4 pins passed in. It's going to assume these are 11, 12, 13 and 15 if we haven't provided these already. The reason it's those ones is if we get our Pico, let me just grab this rather large Pico here so I can sort of show you on here. So what we're talking about, pins 11, 12 and 13. So 11, 12, 13 and 15. I think 13. Oh no, there they are. So, sorry. 10, 11, 12, 13, and then it goes ground, and then 14 is at the very bottom there. So that's why it kind of goes like a weird sequence on there. Anyway, that's the pin out sequence that we have. You can provide any pin sequence you want in there. In fact, on the other one that I've got on the desk that we'll use in a second to demonstrate this, I think it's 0, 1, 2 and 3 for those pins. And then for each of those pins, we basically just say this little piece of code here says self.pins equals the array that's been passed in, and for each pin number that's been passed in there, make it a pin with a pin.out, so it's an output. So for pin in pins, that's what that piece of code does there. Then we've got this stepper sequence. This is the thing that makes the stepper motor actually turn. So if you look on here, we start out with 1, 0, 0, 1, 1, 0, 0, 0, and basically it's just doing 2 phases at a time. So you can see there the phases will change as we go down the sequence. If we don't get that quite right, we'll see a little jitters and things in our stepper motor sequence. So print stepper motor init complete, and then we've got this function that's called move motor. Really should just call it move because motor is kind of a redundant phrase, but it is what it is now. So because this is a class, self just means refer to any variables within here that have self in front of them as the ones that we've defined in this init function. We've got a number of steps that we want the stepper motor to turn, and we've got a direction that we want it to turn in as well. And then there is some kind of delay, so this is just between going through those different steps. So the smaller the delay, the faster it will turn. And I think 0.001 is as fast as MicroPython can turn these stepper motors. If it's any quicker than that, it doesn't seem to get enough energy to actually energize it to turn properly. So if direction is 1, so we pass in, this is a bit naughty really, but we pass in direction as a boolean, as a true or false. And true or false can also be represented as 1 and 0. So really what I should say there is true, and if direction is true. So direction, I think, if it's false, it's clockwise, and if it's true, it's anti-clockwise, I think. So if the direction is equal to 1, then the sequence equals self.step sequence. So that sequence there. That's a little array that sequence becomes. Otherwise, sequence equals we reverse it. So we say it's a list, we're going to reverse self.step sequence, and we'll get the opposite arrangement being passed into sequence. So then we say print moving motor for, we don't need a variable here because we're just going through a loop a number of times. It's however many steps there are that have been provided into this function, how many times we want it to actually move. And the steps don't correspond to degrees exactly, though there will be a number of steps per degree. So we can probably work that out if we wanted to make this even better. So for the number of things that are in steps, and then for each step value in the sequence, we want to say for pin value in, and then zip, we'll unzip the pins and unzip the step values and have them kind of side by side. Zip's a really nice function for kind of pairing up 2 arrays so that they sort of stand in sequence. So pin.value equals value. So this is going to basically, for each pin that we have, for each step sequence, it's going to go through that one at a time for as many steps that we provide in there. So let's go in, and not to say there, you reverse 4-bit binary. Yes, that's essentially what's going on here with this sequence. So it is kind of binary, but also these are just high and low values. So we just represent them as ones and zeros in there. So that's how the class actually works. Now, if we bring that class in there and we create an object that's called stepper, we pass in 0, 1, 2, and 3. Let me go over to our bench. I've got this little step motor here, and if I just go to the full overhead, and I've also got this Pimoroni Pico Explorer. It's got a little Raspberry Pi Pico, and it's got some pins connected up to this motor driver. And you can see here, if I just move that out the way, there is 4 LEDs, and they correspond to the different states. Let's see if I can get that to stay out of the way. So when we run our code, I'm just gonna click run, and then I'll show you what's going on. You'll see that they flash really, really quickly. So what I'm going to do with my code, I'm actually going to change this code. Let me bring this into view so you can see what's going on here. So I'm going to make the delay ½ a second. So we'll actually see, as we say, we're going to move 130 is 90 degrees, I've figured out with this particular stepper motor. So if we do 130 times by 4, we'll get it to go all the way round. And essentially what this code is going to do is make it go all the way round and then go all the way back. But what I want you to watch when I run this code is, and I'll go back full screen, is these little LEDs. You'll see them pulse through. So I go to that one here and I click run. So if I just move this out the way, can you see that they're doing that phasing of the code there? And if you watch very, very carefully, you'll see that arm is moving incredibly slowly. So let's speed that up by just changing the code. I'm going to do it a factor of 10 faster. You can probably just about see that it is moving, so it's moving clockwise, and you can see that it's pulsing through all those different LED states there, but that's way, way too slow. So I'm going to change it for another factor of 10. If I now move it, you can see on the code there, what I'm doing is I'm changing this delay. If I make that 0.0001 and then I run this, this is as fast as this is going to turn. So it'll go all the way round and then all the way back, like so. And you can see on this direction, because this direction is false, we can say not direction to get the opposite of whatever it currently is. So if it's true, it'll become false. If it's false, it'll become true. And we've got that delay in our code there and the number of steps we want to turn. So we can get it to turn, for example, just one step. Let's get it to do that, and you'll barely see it move. It just ticked a tiny, tiny bit. Let's do that again. You can see it's moving ever so slightly. So let's get it to move 10 steps. So it's kind of just barely moving. Let's do 100 steps. That's almost 90 degrees, but not quite. And if I do 130, that should be kind of 90 degrees. Now it looks like it's not quite at 100, like 90 degrees. It's not kind of horizontal or vertical at the moment. So let's try and get that to be what we want. If I just change this code so that we only have one movement, what we could do is just make it go all the way round. Let's do 130, and I'll try and get it to stop at exactly. So let's move it backwards. So let's change the direction to true, and let's make this, I don't know, 10. And we can basically just adjust it. So maybe 5 in the opposite direction. That's probably as close as I'm going to get it, like that. So what we can do now then is we can run like a calibration program. So I did this one as a little program so that I could tweak the robot, because there's a slot which has enough clearance for 90 degrees for the arm to swing round. So if we switch this on, the robot doesn't know what the position of the motor is, because it doesn't record that. There's no way to actually ask the stepper motor what position it is, unlike a servo motor. So we need to sort of calibrate this. So I've written this little calibration program, and you can see there it says print press A for +10, press D for -10, press Z for +1, C for -1, W to change the direction, and Q to quit. And that will allow us to calibrate our little servo motors. If I just comment those out, so you can now see on the screen, if I just move this up, I've got a little calibration program, and I can come along here and I can say A for 10. And the thing with this, the reason that's not working is because I think I've passed in at the very top of the code 10, 11, 12, 13, and we need that to be 0, 1, 2 and 3 for the different GPIO pins. If I do that again, and now if I press A, you can see it's sort of ticking back a little bit there, and we can do D for the other direction. We can do A back again. Looks like A is only going one step at a time there, actually. Yes, it was only doing one step there. There we go. Let's change the code and run that again. So we can use this to calibrate our stepper motor if we wish. Oops, and I've actually just pressed A in the wrong place, and it's just updated my code, which I didn't want it to do. So let me just go and edit that back. Can't quite see this because it's slightly off the screen. Yeah, basically I was pressing A and it was doing this. So I just need to make sure when I run the code, I move my cursor down to this little arrow down at the very bottom of the screen. Right, so I can now do, there we go. So I can do forward 10, back 10. So that looks like it's about right. So I can do Q to quit, and we've calibrated the position, the kind of starting position of our robot. So the next piece of code I was going to showcase, so if I now remove this, if I plug in my other one, which is the actual robot, which is just in front of it. So I'm just going to move this out the way. We're no longer using that one. We're now using this robot just here. I'll just show you on the full camera there, or we can look at it from this view here. So it's got this rangefinder. So what I want to do is I want to run the code and I want to see what the range currently is to test that our rangefinder is working. So I've got some code. This is the same code that we looked at last week actually, which imports our rangefinder. So here's our rangefinder class. So we pass in a trigger pin and an echo pin, and we set those up internally. And then we have this distance property. So property, this got this nice decorator in front of it. This means that we can treat this as like a variable within our code. So we can say whatever the class name is, .distance, and it will actually run this code. Oops. So this sequence, if you've not seen this before, it basically resets the ultrasonic rangefinder. It sends out a pulse, and then it waits for that pulse to come back, and it measures the time between the start of the pulse and the end of the pulse, and then it divides that by the speed of sound, 0.343, and then divides that, times it by the speed of sound and then divides it by 2, because obviously it bounces off an object and comes back, so the distance is actually twice that we're getting back. We then round that up, divide it by 10, and that 1 is just how many decimal points we get back. So if I now go to this little test program here, this is going to test that our rangefinder actually works. So I'm getting a distance of 32.6, and if I put my hand in front of this, you'll see that that distance is going to change. So we can use this in our code as we put our hand towards our high five robot. If it's say less than 10, less than 20, whatever we want that to actually be, it can activate the hand coming round. So what we need to do next then is write some code using those two, the rangefinder and the stepper motor driver, and we can put this in a very simple piece of code. Let's have a look at this. So we bring it in the rangefinder, bring it in the stepper motor, also bring it in time and sleep because we need to do some sleeping things to just put in some pauses. We're going to create a rangefinder object. We're going to create the stepper motor one. So these are just the pins that I've got wired up. And you might be able to make this out if I go on the overhead. You can see there that I tilt this up. You can see that it's just pushed into the back. And because I've not got this glued into place, it's a little bit wonky there, but there we go. So you can see it just there. So this is the paint job. I was trying to print a better version of this by using the actual correct colour rather than just red. Red is what I had on there. So this would have been far better had this actually finished printing rather than printing that mess. Okay, so let's go back to our code. So that's that one there. So we've got a rangefinder, we've got a stepper motor, we've got our direction, and the hit range. This is the distance that we're aiming for to try and start the activation of the hand moving round. So the hit range is just how many centimeters do we want this to detect from. The number of steps is 130, which is the 90-degree angle we want it to turn round, and the delay is 0.001, which is the fastest we can run the stepper motor. So we've got two functions. We've got high 5 and default position. So high 5 is going to move the stepper motor, the number of steps that we've defined there. It's going to make it swing round anti-clockwise, so the direction is false, and the delay is just that really, really quick delay there. That's just going to stop it for a tenth of a second at the end of this function. And then the other one is basically to move it back. So it's going to assume that the hand is fully outstretched, and it's going to move it back minus 90 degrees by saying not direction. So the same number of steps but in the opposite direction. Now we need some way of the robot detecting whether it's already in the high 5 position or not, because if it's already doing high 5 and the distance is still less than that hit range, it's going to swing round further, and that will make it clash with the edge of our robot, because that slot only allows it to swing around 90 degrees. So we need some way of knowing whether we have started that high 5 or not. So I've got this was in high 5 equals false, and this is just a flag to track the current position of our hand, and it's kind of true or false. It's either in that position or it's not. So we'll either move the arm entirely back or move it entirely forward. We could probably get clever with this and know the exact angle that we're currently at and have like a target angle and an actual angle, but I've not bothered with that. It's just true or false. And then we've got a simple loop. So we grab the distance from the rangefinder. So you see you don't need brackets at the end. We just treat it like it's a variable, and that's because of that decorates property. We then say print the distance, and this is an F string, so anything we have in these curly braces we can pass in a variable and it will display the actual value of that. And then we've got two things. So we have an if statement. So the if statement is going to check if the distance is less than the hit range, then we want to check, are we currently in the high 5 position? If we're not, then we can do the high 5, and we can set was high 5 to true. And then next time this code loads round, we can say if the distance is less than the hit range, which it may well be, but the was high 5 is true this time, so it will ignore this block of code and it basically just stay there. When the range is greater than the hit range, so we've moved our hand away, it will then drop through this else statement, and it will say if was high 5. So if it was previously in the high 5 position and we've now moved our hand away, move it to the default position and say was in high 5 equals false. If it wasn't in a high 5 position, i.e. the hand is in its kind of default position already, it'll just stay there. And then we get it to sleep for a second, just so that it kind of moves a bit more elegantly rather than just continually doing this. So I'm going to click run, and I'm going to go to the overhead camera, and I'm going to put my hand in front of this. You can see there, we get the crisp high 5 as we put our hand in front. And unfortunately that's as fast as we can do it, so it doesn't quite seem like a high 5 you'd expect. So if I put my hand in the way there, we can see there he comes round to give us our little crisp high 5. So I can do that, and I can give him a high 5 and then move my hand back. So this is a celebration of 400 videos. There's my little crisp high 5 from the high 5 robot. So if I leave him there, he's basically just going to stay there unless... Now what you can do, which is quite cool, if you record a video, let me just grab this as a little video. So let me just go to for me for a second. So if I put this into like front-facing mode, so that's what you look like when I look at you, that little camera just there. If I put this onto the that view there, and I record this, as I move that forward, as I move towards the robot, he'll sort of swing round to do a high 5, so it makes quite a nice little video clip for that. So that's the robot. That's how we can make a little high 5 robot. So as long as it's something, let's try out some different positions. If I just stay there, let's see what happens. If I just keep my hand there, the hand will stay there until I'm out of the range, and then it'll return back. And because it starts from that back position and returns to that back position, it should always be in the kind of correct state. So you can see here that this is what I was trying to improve. This was supposed to be, I printed this in red PLA just because that was what was on the printer, and I thought I will spray this with some spray can, some spray on enamel, and I didn't put any primer on it. So unfortunately some of the edges look pretty nasty there. But I'm quite impressed with how this this hood looks, and the way that the face looks, and the fact it's kind of got like a roundness to it that also gives it a nice kind of dimension. Not sure about the hand, but I think it's good enough. Let's move that around a little bit so you can see that. There we go. And if we do that from the overhead camera, you'll see I had to make sure that clearance for the hand with the Pico and all the other parts of the robot worked well as well. There's nowhere for this currently to go. I should probably mount that somewhere at the back of the robot, maybe on like a little base, something like that. But yeah, you can see how this works. There we go. So yes, all the files for this are available on kevsrobots.com. Let me just grab that up on the screen, and I can show you the walkthrough that I've created for this. So I'll go to kevsrobots.com. There we go. Let me just bring this down here. Now share my screen. Oops. That looks weird. Why has it done that? Let me zoom to the app. There we go. Right, it's because I've got two windows open maybe. Let me just sort that out. So, yes, there's a second one. There we go. That's why. I'll go back to that now. There we go. Right. So yes, High Five Robot is the robot that's currently being displayed there. So if we go into this, you'll see this video you're watching now, and you'll see all the design goals for this. So detect a hand using ultrasonic rangefinder, move the hand using a stepper motor, be powered by a Raspberry Pi Pico, and be a fun project for the 400th YouTube video. So the bill of materials, it's about £7.45, so it's quite cheap to actually build this one. We just need a microcontroller Pico, a stepper motor, a rangefinder and some screws, and a 3D printer with some filament in it. And you can see there's that sequence that we have. So that might look slightly different than the sequence I had in the code earlier. It's essentially just moved up a little bit. It doesn't matter where you start as long as the sequence is run through in that order. It doesn't matter where you start. We've got that slide there about the phasing, about the wiring, so that's all on there with a little table as well. And how to assemble it. There are all the 3D printable parts. You can see there's the building up of the robot as well. So that was actually inspired by a film. I don't know if you know which film that could be possibly inspired by. I think it was a little Coke can or something like that. Does anybody in the comments know what I'm talking about there? It's more of like a round robot. Was it called Weems, maybe? And that had like a little hand that appeared from the back. So the code is there. This is also created this using GitHub gists. So GitHub gists allow you to embed code in there, and you can encode many different files, and as you update them, they will also get updated on here as well. So there's the full set of files. You'll need to copy the rangefinder, the stepper motor, and rename that hi5.py to be main.py if you want that to run autonomously. And there's the 3D models as well. You can sort of spin these around and have a look at them on the site as well, and then just download them if you want to have a copy of them. So there we go. That's the write-up on the website. Cool. So let me get back to our slides. Okay, so yes, if you want to get yourself some last-minute merch for Christmas for somebody, I don't think we'll be able to send these out for Christmas now, but yeah, you can get yourself one of these amazing Robot Maker hats, available in a few different colours. I think I might order myself some different colour ones for the new year. You can also get the mugs, they're quite nice as well, and the t-shirts as well. Yes, so kevsrobots.com/merch for those. And if you want to join our Discord community, we fixed that issue that we had with the Discord link. That should be up and running again. So if you go to kevsrobots.com/discord, you'll get a sign-up link in your email when you send that through. And that'll also give you the option to sign up for the newsletter as well, which I've just sent out today. We have quite a few videos to go through on that one. And if you want to follow me on social media, I'm all over social media. So you'll find me at Mastodon.social. I don't know why I started there. I'm on Threads at Kevin McAleer at threads.net. I'm on TikTok at Kevin McAleer6. I'm on Instagram at Kevin McAleer. I'm on X at KevsMac, and I'm on Blue Sky at kevsmac.bsky.social as well. Blue Sky and Mastodon Threads seem to be pretty nice places to hang out nowadays, so you probably find me on there as well. Cool. And if you want to join and support the channel, you can do that in a number of different ways. You can get your name in the end credits by going to kevsrobots.com/coffee, and there's a number of different ways you can do that. Doing a super thanks, a super chat, joining the YouTube membership program, or buying me a coffee. And I think, in fact, Ford has just done a little super chat as well. So let me just bring that one up on screen. There we go. So thank you very much, Ford, for the $2 tip for the 400th video. Really appreciate that. Cool. So let's give a shout out to everybody that has actually supported the channel. So let me go over, press this button here. So coffee wise, you can see we have is that right? Yes. So Johnny and Marie and Michael bought coffees in the last 30 days. And member wise, we've got Marie TKD, we've got Andrew, Shemi, Jeff, DN Corty, Marlene and Tom on the Buy Me a Coffee YouTube membership program, and the Buy Me a Coffee membership program. And then on the YouTube membership program on the right over here, we've got Marie May, we've got Michael, we've got Stephen, we've got Ford, Bello, Oxrad39, Littleback, we've got Paul, Johnny, Handsome Cheerlights, Prem Kumar, we've got Stephen, John Paul, Alistair, Cassie, Tinkering Rocks, Johnny Bates, and of course we have Tom. So thank you so much for supporting the channel. It means so much to me. It'll also help me repair my 3D printer, which is now looking quite nasty like this. I can't believe that happened, but luckily I've got a bit of a parts bin with some spare pieces, so hopefully I can get that up and running without too much faff. I've actually got two 3D printers, and the other one hasn't been working for months now. There's something wrong with, it must be the cable, so I've actually got a spare set of cables to fix that up as well, but hey. So it's at this point in the video, YouTube will suggest over here another video for you to watch from the over 400 videos that are now available. It may actually be more than 400 videos, but yeah, that's the official number from kevsrobots.com when I update a sheet every single week with the new videos, including the shorts as well as the pre-recorded videos. So yes, it'll suggest a video here for you to watch next. And it's at this point in the video, if you're watching this on replay, I'll say thank you so much for watching, and I shall see you next time.